That privacy toggle in your AI coding assistant looks like a secure lock, but it often functions as mere decoration. When XAI open-sourced its Grok coding tool, developers discovered the "improve the model" off switch had no effect on local file uploads. The collector operated entirely outside the tool call permission system. The prompts used to monitor an agent's activity simply could not see the outbound data. The scale of this exfiltration was massive. While the coding conversation required only 192 kilobytes of data, the tool transferred 5.1 gigabytes of local files to a cloud storage bucket. It captured entire Git repositories, including deleted files containing unscrubbed passwords and SSH keys the agent never even opened. Approval dialogues only protect against what an agent explicitly asks to do. For autonomous background processes, these interface prompts are cosmetic illusions rather than security boundaries. This vulnerability extends to the infrastructure level. Hugging Face, the central repository for the world's AI models, recently disclosed a production breach. The entry point was a set of malicious datasets. These uploads exploited code execution flaws within the platform's data processing pipeline, turning the core product into a weapon. An autonomous agent swarm drove the attack, executing thousands of individual actions across ephemeral sandboxes over a single weekend. This speed allowed the intrusion to be compressed into a time frame that frustrates traditional forensic analysis. Cybersecurity defenses built for human response times are becoming obsolete as software begins to attack at machine speed. Granting AI agents full, unsandboxed access to an operating system creates a catastrophic risk profile. A bug in the Codex model recently illustrated this when it mistakenly deleted a user's entire home directory. The deletion resulted from a routine reasoning error while the model attempted to override an environment variable. Without a sandbox to contain the error, a simple calculation mistake became a total system wipe. In the agentic era, hard architectural sandboxing is the only layer that makes routine machine errors survivable. Beyond system security, developers are disabling their own cognitive firewalls by delegating too much to the machine. A controlled study of 52 software engineers measured the impact of AI assistance on task performance and comprehension. The AI group finished just 2 minutes faster, but on a comprehension quiz, they scored 50% against 67% for the unassisted group. This gap widened most in debugging. When hitting an error, AI users lacked the understanding to fix the architecture. Accepting AI output wholesale trades vital comprehension for an illusion of speed, leaving developers defenseless when the code eventually breaks. This loss of comprehension manifests on the balance sheet as endless rework and defect repair. A longitudinal case study recently compared the true cost of using local, on-premise models against cached cloud APIs over a 28-day period. The data revealed a 74.9% fixed commit ratio for the on-premise configuration, meaning nearly 3/4 of the AI's work required a manual fix. The cloud API setup, by contrast, maintained a much lower 45.9% repair rate. The token sticker price is a poor guide to actual value. The true cost of AI is paid in engineering hours spent repairing machine errors. Scale and raw capability are redrawing the map of open-source AI, turning model weights into a geopolitical asset. 2 recent releases highlight this shift. The American model, Inkling, is pitched as a malleable base for customization. Meanwhile, China's Kimi K3 is a 3 trillion parameter heavyweight that trails only a single commercial model on global leaderboards. The origin of frontier open weights is now a geopolitical fact. Free to download no longer implies a compromise on performance. Upgrading to the newest, largest generalist model is often a step backward for specialized work. The Dharma OCR model, for example, maintains a massive performance lead over generalists like Mistral OCR4 when processing degraded Portuguese documents. Generalist models encounter complex scans by generating fluent, fabricated sequences that look plausible but are structurally unusable. They hallucinate data rather than failing safely. Allocating a parameter budget to a single domain acts as a firewall against the data corruption inherent in general-purpose models. When software permissions and cognitive boundaries fail, the security perimeter must move to the physical world. Google DeepMind is now adapting SynthID, originally used for watermarking digital media, to the physical DNA synthesis supply chain. This transforms manufacturing hardware into a security choke point. If an AI designs a restricted biological sequence, the physical synthesis machine recognizes the watermark and blocks production at the source. Surviving the agentic era requires becoming your own perimeter. It demands a reliance on physical hardware limits, strict system sandboxing, and a commitment to personal technical mastery.